Hello. So what I'm going to be talking about today is an experience report, really, about our adoption in the company that I worked for of event sourcing as an architecture and the mistakes we made. So we were building a brand new system. We adopted event sourcing. We were new to it. We made a number of mistakes. Some of them really obvious, some of them less so. And so what I hope is that I can share those mistakes today, and those of you who are new to event sourcing as well will be able to learn from our failures and avoid them. But we were able to recover from those mistakes quite easily, and reflecting on that, uncovered some useful lessons learned as well about our successes. So hopefully you'll be able to learn from our successes as well. It's not all bad news. I was working as an architect and technical lead of a business area in a company that does scientific publishing, and we were building new systems for the editorial workflows and peer review of open access science content. So the editorial process can be summarized at a very high level like this. Researchers do some research in academia or industrial research laboratories. They uncover some new scientific learnings, and they want to publish that to the wider scientific community. Are you having problems? They write up their findings and submit the article and data to a publisher, such as the one that I was working for. The publisher then finds peer reviewers also in the scientific community. They review the science, decide what changes need to be made to it. Right, scientific publishing. Scientists do some research. They write it up as an article to be published in a journal. They send it to a scientific publisher. The publisher decides whether it's fit for their journal. They send it out to other scientists to review. Go through rounds of revision until the peer reviewers agree that the science is acceptable. It then gets typeset and published, and then researchers read it, and then it feeds back into the ongoing scientific discourse. Maybe it's not fit for publish, it gets rejected, or maybe it's not fit for that particular journal, in which case it will get transferred to another journal, and there's the opportunity to submit to that journal. Okay. So it turns out that not all scientists are always entirely honest. And so a significant part of the publishing process is to detect scientific fraud. So early on during submission, we might try and catch plagiarism or double submissions where a paper has already been submitted to another journal. But some scientists can actually form more sophisticated fraud rings where they agree to review each other's papers favorably and so on. And so the data that comes out of our editorial systems is fed into another part of the business that perform what they call research integrity analysis, where they look at the patterns of data of submissions and reviews, trying to detect potentially fraudulent reviewer and author rings. So that was the system we were building. The bit that's sort of in dark blue there was the areas of the business that our system was responsible for supporting, and we would have to feed data into this research integrity analysis and downstream to publishing. So this is a very linear view of what publishing is, but actually these activities happen at many times in sort of multiple feedback cycles. People can provide data at different points in time. And the systems we had, the legacy systems, took a very linear view, and that was found to be quite a limiting factor. So we wanted to build a system that would not be so linear, where the people using them wouldn't have to maintain a lot of data outside the system in spreadsheets and things like that in order to have it at hand when the system then allowed them to enter it, for example. And so we tried different ways of presenting the business and our technical solution, different metaphors, physical and cognitive metaphors, to the business, to product, to technology, in order to create different ways of thinking about the problem and envisaging how the system should behave. The one that we found very useful when talking with product owners, product directors, was the idea of containment and facing. Right? So we had the idea that the core model of our bounded context, which is basically the state of articles going through peer review as they get moved from journal to journal and eventually get published, is a sort of the core of the system, and access to that and changes to it are mediated by peripheral applications, and those peripheral applications face out to different segments of our user base and have user experiences that are tailored to their specific needs and constraints. So somebody who is a journal editor is looking at hundreds of manuscripts at once, needs a very different view from someone who's an author or reviewer who comes to our systems maybe once or twice a year at most and needs a lot more guidance and a lot less data sort of in their face at once. So each component of our system that's sort of facing out to different users is used by that user to input data. They acts as a scratch pad. Right? Input data, and when the data has been collected, it gets submitted to the core as a command, and then the command then updates the state of the articles and can then invoke other applications to trigger workflows that need to be done by other people who are involved in the overall process. Each of these systems could fail independently or be taken down for operational reasons. So each had its own database, and we were using REST to integrate them. And then we wanted to attach provenance to the activities that were being performed by these different users. That is, we wanted to know who was doing it, how do we know who they were, where were they when they did it, when did they do it, and so on. And we wanted to be able to record this over time so that we could look for or capture this data and look for suspicious patterns of provenance in the changes that happened to the articles that were being reviewed. That led us to picking an event-sourced architecture. Each of the peripheral applications was used to capture information and then submit a command to the core of the system. The command would be executed and record what happened as events. The current state of the article would always be rehydrated from the history of events that applied to that article. And then each of the events could have the provenance associated with it so that we could then do analysis on that for a later date. And the event sourcing architecture, we thought, would force us to be honest about the current state of the article and how it related to the history that it had gone through. We couldn't store an audit log that later could not be used to recreate the current state of the article. We would always have to ensure that the event log, the event history, was an accurate reflection of the current state. We picked some very boring technologies. There's in fact, boring technology is a meme, and there's a website that campaigns for it. So we were building on Cloud Foundry as a cloud platform. We had an internal cloud and cloud in GCP, so we had a common layer above that. We were writing on the JVM in Kotlin. That was probably our most exciting technology choice. We were writing very lightweight services using a framework called HTTP4K that allowed a very functional programming style of writing HTTP. And we were using Postgres to store our data. Postgres because we had a lot of operational expertise in-house with running Postgres, point-in-time recovery, high availability, just the general work of keeping Postgres up and running effectively. And so that's why we picked Postgres rather than a dedicated event store. So we were new to writing an event source system, and we did read papers, books, we watched videos, we read experience reports, but we still made some rookie mistakes. So let's go through some of the mistakes we made. We were seduced by the dream of scalability and eventual consistency. So I wrote an HTTP service for storing and receiving events, which meant, although that each event was being put into the store transactionally, anything that wanted to process events was not transactional, and that has obvious failure modes where maybe processing of an entity would create duplicate events. Yeah, stupid mistake. Our system didn't really need like huge volume. It didn't really need consistency. What our constraints were really was trustworthiness, robustness, and consistency. And so this was like an architectural error that caused us pain later. Our command processors maintained a current view of entities. So the current state of the entity was calculated from the events, persisted in a database that allowed the application to select and filter sets of events that users needed to look at. So an editor of one journal would want to see what needed to, which articles needed processing for their journal, and an editor of a different journal would want to see for their journal, and not both. So we had a relational model of the current state of articles in play that allowed easy selection of and filtering and prioritization of articles. However, rather than creating that snapshot projection from events as they were read, as would be a canonical architecture, the command processors maintain that current view at the same time as recording events. So yeah, that didn't work very well. We had the current store was relational. The events were blobs of JSON in a table in Postgres, and so the migration effort of keeping those two different models up to date became an overhead during development. I think one of our most significant mistakes, this relates back to what Udi was saying during the keynote, is we got confused many times between event-driven and event-sourced. So in an event-driven architecture, events are passed, they're quite transient, they're passed around between components, code reacts to them and makes state changes and invokes behavior, maybe in systems that are outside our transaction boundaries, like email sending and things like that. While in an event-sourced architecture, the current state of an entity in your bounded context is derived from the history of all the events that have happened to it in the past. Quite different, but if you start trying to trigger behavior from the events in the event-sourced store, the event history store, which is the mistake we made, you start finding that you have to know what you're trying to do when you actually folding those events into the current state. Are you meant to be reacting to them in order to invoke some behavior, or are you just reconstituting the current state of the entity? We noticed that code had flags to say, I'm currently reconstituting an entity, or I'm sort of live. And the domain logic started getting confused, and also started getting full of information about our technical choices, right? Whether we had an event-sourced architecture or not. And that became like more and more difficult. Luckily, quite easy to spot. We had put notifications into the event history service to allow remote components to be notified when new events were added, so they could pull events and update a local projection, which was useful for CQRS, but had the end result of people using the event bus, the event history as an event bus. So that exacerbated the confusion between event sourcing and event-driven architectures, and started being used for transient events that had no real relationship to the business. We noticed that the business users were asking us to filter events out of the view of the history of the articles that they were interested in because they made no sense to them. Red flag. So we had events in there like, tried to send an email to Bob, but it failed with an I/O exception. And very technical events that were used to trigger behavior in the system and weren't recording interesting information about the business process and how what had happened, as would be interesting to our business users. So a number of mistakes were made. We noticed them in 2 forums. We had morning tea, English. So the team would gather in the kitchen every morning for tea. We would always have pads of A3 paper and pencils, and over tea we'd talk about how the project was going and any concerns we might have, among other things. We're quite sociable. And so when sort of issues would be raised up, we would brainstorm it on the paper, think about different ideas, and be able to jump on them very quickly. So even if it took a while for the issues to sort of filter up, we'd typically within 1 or 2 days be able to discuss it within the team and come up with a solution. We record that as an architecture decision record and make that decision and then implement it. So we wouldn't dig our hole too deep for changes that were sort of problems that were very obvious in our day-to-day development. We were quite a big program of work, so we had multiple teams working on this, and we had regular inter-team architecture discussions once a week that we called the Wizengamot after Harry Potter. And so we would get together, all the people from different teams would get together and discuss larger architectural concerns, typically about integration between different parts of the systems, but also about some of the sort of philosophical, what is the best way of doing event sourcing? Are we doing it consistently? We're seeing this problem and it's caused us this. Because the teams were moving at different rates depending on what they're working on, some people had got further in their journey through event sourcing and adopting the event sourcing architecture than others, and we could discuss like the sort of trade-offs that we were finding we had to make in a bigger team and share that knowledge around the whole department. And certainly the one that caused the most, I guess, consternation was the storing of the current state in our command processes. So, like, if you hear about, when you first see that, I imagine a lot of you are thinking, haven't you just missed the entire point of event sourcing there? Surely you should just be generating events in your command handlers and not maintaining this what should be a projection from your event history. And yes, that was the conclusion we came to. We had quite big teams, well, small teams, but quite a lot of us in different teams, and a lot of people came from quite different technical backgrounds. So some people like REST, some people like event-driven architecture, some people like relational modeling, some people like putting JSON blobs into document stores, some people like serializable transactions because it makes it easy to think about things. Other people were happy with eventual consistency. Some people like functional programming, and other people were more keen on object orientation and the hexagon architecture. So we were finding a sort of development design culture that allowed people, to balance all these different backgrounds and come up with something that the team could work comfortably in. Okay, so there was creative tension, and that created a design that maybe wasn't entirely by any specific book, but was a balance between, doing things by different books. And maybe as sort of team lead for that whole business area, I was being a little Machiavellian. I could see that the architecture was not evolving into a canonical event-sourced architecture, but I wanted to see what would happen, right? Just because this book says this is the right way to do things, there's plenty of other books that say other things are the right way to do things. So we're going down a particular route. We're balancing preferences of a number of engineers who are all experienced, skillful engineers. They've got good judgment. Let's just see what happens. And maybe this is a good trade-off between different ways of doing things, or maybe it's not. I also wanted to build an intuition for everyone in the department, myself included, about, to build engineering intuition about event sourcing because it was so new to us. Where does it become difficult? Where are the edges where this particular architecture is going to cause difficulties? Where's the sweet spot where it's really paying off? I wanted to build that, and sometimes making mistakes and then recovering from them is a great way of actually learning those intuitions. So we continued that way for a bit, and until the drawbacks of the mistakes we had made became, basically so apparent we couldn't really deny them anymore. And then we decided, where should we go back to a canonical architecture, and which parts of our hybrid architecture are worth keeping. So, what did we decide to do? So the first thing we wanted to do was address this confusion between event sourcing and event-driven architecture. The word event is used for so many different things. And in our systems themselves, we use the word event for many different concepts that were actually very distinct. We had monitoring events that were fired from our application into our active application monitoring infrastructure. We had events that were sent on RabbitMQ message queues. We had events in our event history. We had user interface events in our JavaScript. So the word event was being used for things that needed to be treated very differently. And so we made a concerted effort to change our terminology when talking about events that were put into the event-sourced or the event history. And so we went through a number of attempts to come up with better terminology. We tried saying business event versus monitoring event, but really I think it's the word event that was causing us problems. Just before I left, people were using the term historical fact for something that was in the event store, and historical record, not event store, in order to prevent people getting confused and using the event store as a communication mechanism to trigger activity in the system. Because we noticed that every time someone new joined the project, they would end up making the same mistake, getting the same confusion, and saying, wouldn't this be easier if we just triggered activity from the events in the event store, and we would have to take them through the same learning process that we've been through. So we started changing our terminology to avoid that. But once you've got a code base under continual development that's got the word event written all over it, that takes a bit of time. So yeah, I'm not sure. It was something that we found very difficult to do, and I don't think we ever fully succeeded. Once we decided not to use our event history as a message bus, we went back to using REST and HTTP for integration, as we had been doing it from the start, and particularly we learned very heavily on the use of hypermedia in REST architecture, which allowed us to write all of our peripheral applications and the core as context-independent components. Any component invoking activity in another component would have to pass a set of links to that component to say where data and notifications would have to be sent back to. And that allowed us to easily integrate our new components in with our legacy systems. They didn't know whether they were part of a new or old system. They only reacted to requests by following the links that they received. And we could invoke our systems from test tools as easily as from the rest of the system. And also it made it much easier to decouple release cadences because we could evolve the on-the-wire formats that different components were using to communicate, and use HTTP content type negotiation to choose the specific format for any communication between pairs of components. And then components could sort of be deployed and evolve their formats independently. And we had a convention that you'd never go more than one or two versions behind. And therefore, we could deploy all these different components at different rates across the organization without having to do lockstep deployments. What we found with trying to use event-sourced or event-driven architecture for integration is that you can't really negotiate the format of an event once it's been recorded in a message queue or in an event history, as we made the mistake of. And while direct integration allows us to negotiate those formats on the fly dynamically. We made command handlers transactional, kind of obvious thing to do, but so we connected our command handlers directly to the event store database and ran transactions. We used the HTTP service only for reading out events so that other applications could build projections, and for feeding the data up into Google Cloud for analytics. We also found it was really useful to have that read-only view for hack days. Developers would use it to gather data and visualize it, and those visualizations turned out to be really useful and popular, and some of them got folded back into the product. So that's cool. Then the biggest change that we had to make was to remove the maintenance of the current state from the command handlers, and we turned it into a read-through cache. So this is like moving from our hybrid clunky architecture into a canonical event-sourced architecture. So we would treat the current state as a snapshot. Every time a component wanted to read it, it would grab the current state from the snapshot. It would read in any events that needed to be applied to bring it up to date. It would perform its business logic. It would then save any events, and then in a different transaction, it would save its latest up-to-date snapshot of the entity back to the current state, but only if its view was newer than the one that was in the database. That allowed a bit of concurrency so that multiple command handlers could be running in parallel on the same entity, and if they overtook each other, you'd always just save the newest one, sort of like a compare and set. And then over time, we removed the relational model and just stored JSON blobs for the current state. A number of reasons for that. We had existing infrastructure code and working practices for evolving the persistent data in our persistent JSON data in our databases concurrently with live transactions, so we could evolve our database schema or stored data structures without having to pause the system or without having long-running transactions that might cause an undesirable pause of the system. And we had lots of code already there for serializing JSON structures. And Postgres, we lent heavily on Postgres. Postgres can store JSON effectively, efficiently, and it can index on arbitrary properties inside your JSON. So we didn't need to denormalize our data into relational columns just for indexing. We just indexed directly on the JSON data so that we could still efficiently pull out rows from that table. I think some of our components eventually moved to building their caches concurrently rather than as a read-through cache, just because they were working with larger chunks of data. But most of our systems were built on an event source model. So we made the mistakes in the first one. We made slightly different mistakes in the later ones, but nothing as drastic. And so as we added different systems that we built were also built on the event source model, we all ended up basically doing it like this. So how did we recover? So we were, especially the change of the maintenance of the current state, we were a bit worried about the amount of time that it would take. But it took one of our developers about an hour to switch the system architecture over from like the sort of hybrid clunky way we were doing it to a canonical event-sourced architecture. We then ran the two implementations in parallel for a bit, just to make sure that we hadn't changed the behavior of the system. We hadn't, and then we deleted the old one. that was actually, we were really surprised how easy that was. And so the next question we asked was like, why was it so easy to switch over quite a significant architectural change in such a short amount of time? We'd made some mistakes in our architecture, but we must have got some things right. Okay, I think that one of the key architectural decisions that allowed this to be done so easily was that we'd built our system on the hexagonal architecture. In the hexagonal architecture, the domain model and business logic of the system is implemented in the abstract, independently of any technical underpinnings that allow that system to be connected to real-world technical infrastructure. So we had a functional model of articles, authors, so on, and an OO model of how we find articles in our database and the commands that are being passed in to invoke changes on those articles. All the interfaces by which the outside world can affect change and how the business logic wants to then cause notifications to go out or data to be persisted are defined as abstract interfaces in our domain model. We have an adapter layer, that's the sort of middle hexagon of the hexagon architecture, which maps those abstract interfaces onto technical infrastructure, such as the database or HTTP routing. And then we have technical infrastructure, such as the HTTP for K library for HTTP routing, or Postgres and JDBC for the database. So the abstraction that was used to get the current state of an entity in our system was completely abstracted away from how that current state was maintained. And so it was a short, very quick job to change the algorithm there, and it just plugged into the business logic very easily without any changes. We had extensive automated tests. We had extensive functional tests that tested that the system met the business needs of our users. We had a lot of unit tests around specific algorithms and about the integration with the infrastructure in the adapter layer. But it was a functional test that really paid off. And we wrote our functional tests entirely in terms of the domain model. They had no technical details in them. They didn't have any details of the user interface. They didn't have any details about databases or HTTP or JSON or XML or URLs or anything like this. They were modeled in a domain model. And that allowed us to easily change the infrastructure and then use exactly the same test code. There's no changes to the test code required in order to rerun the tests against the system. And that gave us a lot of confidence that the changes we'd made to the architecture were not affecting the essential behavior of the system. We integrated and deployed continuously. So all the commits that developers were making were committed straight to master. They then went through a suite of extensive tests that would they'd get deployed into a test environment, and then our integration with the cloud environment would then be tested, and then they would get pushed to live if all the tests pass. And releasing them was controlled by feature flagging, and each component, the compatibility between them we tested with consumer-driven compatibility tests that were our build infrastructure that was provided by an engineering support team in the organization. Each component, its repository, you could declare the dependencies on other components, and your client tests of that component would be run in the service components pipeline. So that allowed us to write very focused tests around integration between different parts of the architecture, and then our functional tests would say, well, yeah, they can talk to each other, and the overall composition of them is doing the thing that our business users need. And if you think that every commit that you might push will go straight into production. You have to have good test coverage. So that also fed back into having good test coverage when we wanted to make architectural changes that supported as architectural change. And those automated functional tests, because they were written purely in terms of the domain model, then enforced our use of the hexagon architecture. So we were using a pattern for our test called the Screenplay Pattern, which directly models the different users of your system in your tests. And we used that model of users to also abstract away from how the test is going to interface with the behavior that it's trying to test. So if we had an actor representing one of our users, an author, say, or an editor, that actor would be playing the role of an author, say, and its API would be defined by an abstract interface, and that interface would have commands and assertions on it that authors would submit a paper. I can see my paper, I can change the title, that kind of thing. Right. And then we would have implementations of that interface with the system at different scales or at different interfaces. So we could interface directly against a domain model in memory and run all our functional tests very fast and also very reliably, but only testing the functional, the business logic, and not how that business logic might be affected by the technical infrastructure that we're deploying on. The same test code could be run in an HTTP configuration where the actors were integrating with the system service interfaces, HTTP and JSON, and then we could run that against a system that had been spun up on the desktop or in a cloud environment. So we could have a cloud environment that had more concurrency and also included caching and things like that, and that would then catch errors where we were getting our cache headers wrong and they were incompatible with our cloud infrastructure. We could put a web browser in there and we would be testing exactly the same business logic, but the actor would now be interacting through Selenium and the browser with the user interface itself. So if we'd made some errors in our JavaScript or HTML or CSS, we would be able to detect that. And we could run these tests also against production. So we built our system to be testable in production. And we could then spin up tests, run them against our production environment with all the events, all the commands flowing in would have a test flag set, and the events that would get stored would be flagged as tests. They wouldn't be visible to real users, but our testers could go in and see the effect on the system. And we could use this to also see whether our system was still compatible with the CDN. Right. But the key point here was that all these tests were testing the same business logic. Right. That little hexagon that's replicated across the world in different data centers is the same hexagon that we're running in JUnit in memory in our test suite, in our IDE. And so the infrastructure doesn't add any extra business logic, but it can stop the business logic being invoked correctly. But what it also means is that because these tests have to be written to be able to run directly against a domain model in memory, you can't put any business logic anywhere else but in your domain model. And we would have constant discussions in the team about, is it worth maintaining this additional configuration of an in-memory test? Because, well, it's like we've got HTTP, we've got browser, and we've got in-memory. If we could just get rid of one of them, we'd only have 2/3 of the amount of test infrastructure to look after. Every time people were complaining that it was that it was difficult to write a test directly in memory, we would look into it and we would find, oh, that's because we put business logic in the wrong place. You've got business logic in the HTTP routing layer, or you've got business logic in your persistence layer. We'd refactor the code to move the business logic into the domain model and represent in the domain model a more accurate reflection of what our system is doing, and then the difficulties of maintaining that in-memory test configuration dissipated. So eventually, we were quite happy doing this, using it as an architectural constraint. And that architectural constraint really paid off when we had to make big architectural changes, switching out our misuse of the event sourcing architecture for something that was more canonical, our tests, therefore, were ready to support us. And all our business logic was like separated from the technical code that we were re-engineering. So those tests gave us a lot of flexibility for quite large-scale technical architectural changes. So, lessons learned, 3. Right. I think thanks to this experience, we did gain a much deeper intuitive understanding of the trade-offs, sweet spots, difficulties that are inherent, in an event-sourced architecture, but also it gave us a good understanding of the value of a hexagonal architecture, and also the value of acceptance test-driven development process. So not bad for an hour's refactoring, I think. That's money well spent. 3 specific lessons that I took away. Right. I think that the mistake we'd made was not being really clear about, in an event-sourced architecture, what is a command and what is an event. We had got confused by some of the literature saying that event-sourced architecture and event-driven architecture are orthogonal. And basically, we had misunderstood what the writers were meaning by orthogonal. So distinguishing between an invocation that is going to change the state of the system, cause behavior to happen that maybe is irrevocable, and a fact that has been recorded about something that happened in the past is absolutely key to event sourcing. And if you mix those 2 things up, the architecture can become very messy. It also means that you might never be able to properly replay your events because they're expected to create irrevocable changes, and you have no way of creating the same change because it was never recorded. So if I was building an event-driven architecture, I would create a clear distinction between events that are transient and causing changes to happen that are flowing across the wire, say, and facts, historical facts that I've recorded about things that I did in the past. And event handlers would be in the event-driven architecture, would be performing commands in the event source architecture. And you can see, talking about that gets really confusing. So that's where our change in terminology, so like recording facts in the historical record becomes a lot clearer, especially when you've got an event-driven architecture and event sourcing. And for us especially, this was a much more important lesson to learn than command query separation. We did have some command query separation, but the distinction between command and query, I think, is nowhere near as significant as between command and historical fact. Event sourcing plays really well with other architectural styles. So in our case, we used event sourcing for the domain and data model. We used the hexagonal architecture within our processes, within our Kotlin code. We had CQRS for data flow within our applications, but we didn't expose our event history to any other applications outside a single team. So it was purely intra-application, intra-team, and that allowed the teams to evolve the event formats in the event history as they saw fit without having to coordinate with lots of other teams, and they could rely on REST for that. And so we used REST to integrate applications both within the organization and also outside the organization, especially leaning heavily on content type negotiation to decouple release cadences, and hypermedia to decouple the sources and sinks of data and control flow. And avoiding any technical detail in functional tests is extremely powerful. A functional test shouldn't be talking about what buttons are being clicked or that kind of information. It shouldn't be talking about JSON formats or URLs or databases. It should be written purely in terms of the domain model that helps you use them as an artifact in which to discuss what the system should do when you're talking with people who aren't technical, who aren't on the development team. And it also means that they're decoupled from the architecture, and when you make architectural changes, they're supporting you in those changes rather than slowing down those changes because they need to be modified as well as the architecture changes. And so using the hexagon architecture and the screenplay pattern, those two things fit together really well to allow us to make that happen. Thank you.
All right, so we have a bit of time, so if you have questions, Nat would be very happy to answer them. So there is a mic over there.
Can you pass it through? Yep, sure.
Brilliant.
I was wondering, you said you had a lot of technical details in the event store because it was used as a messaging bus. So I imagine you had things that were commands and hooks and stuff like that stored in there. Did you end up cleaning it up? Did you take that freedom, or did you just leave it there? What happened in the event store? Did you touch it at all, or did you leave everything as is when you migrated away?
Yeah, so we didn't have commands in there. They were events, and then the system would look at those events and decide what to do on a regular basis, triggered by schedulers, for example, or notifications coming from Postgres. But they just became obsolete when we changed the way the architecture worked to not rely on those. Luckily, we caught them really quickly. So that was something that never had to go to production. We caught it during our regular chats over tea. And so that, yeah, I mean, we never actually recorded those events in production. The code might have gone to production, but it didn't actually affect it, But we weren't a regulated industry, so we didn't really have to keep the original events in their original form that they were first recorded. So we could run migrations over the event store, and we did occasionally go in and delete events that were no longer necessary. So, for example, because we were running tests in production, we would have a lot of events that were marked as test events, and they were just not important to keep. And so every now and again, we would reap those.
So you mentioned about events that don't mean anything to your users. One pattern that I've been using is accepted completed. Right? And that's obviously meaningless to users. Are you saying you'd write that stuff off in almost a separate stream then? Do something, and then when that's done?
So we did have, in our architecture, we had something similar in that we would, for example, if you wanted to invite a reviewer to review a paper, the editor would go invite that reviewer. That would be recorded as an event. Right? And then we would have to know that we'd actually sent that. And this was something where we hadn't come up with an answer that made us all entirely happy. And the same with RESTful interaction. Do we store URLs in our events? In one of our systems, we received a command coming in, we have the links back, we would store the links in the event, but it felt wrong to put links to systems that might come and go in a historical record of business process changes that would probably have a longer lifetime. And so, to be honest, we didn't have one answer. For email sending, we had the editor has invited it, and we actually sent them an email, and users were happy with seeing those, even though it was a result of a technical decision that those two things had to be separate. In terms of RESTful links, we never showed those to the users because they wouldn't have cared about them. And I think if I did it again, I would keep the RESTful links in a separate table relating to interactions with other systems rather than putting them in the event store. I think that was another mistake we made, putting those in the event store.
So you said you used the hexagonal architecture. So how much does the domain model know about event sourcing? Do you keep that completely agnostic to the event sourcing, or does it know that it's being event sourced when you're using the hexagonal?
Yeah. To be honest, it's a bit of a grey area, right? So the abstraction that we used on the persistence would be like, give me the current state of the entity, right? And that was abstracted entirely away from the fact that it was recorded, whether it was reconstituted from an event history or just loaded from the current snapshot. But the logic knew that when it did something, it recorded an event. Right? And so I guess we were somewhat lucky in that we'd put the reconstituting logic behind that interface somewhat in the adapter layer, right? Or rather, we'd loaded it from the relational model in the adapter layer, and therefore it was a perfect place to put the reconstituting from a stream of events. If we'd been entirely canonical in our event-sourced architecture from the start, the fold over the event history to create the current state would have probably been in the domain model, entirely abstracted away from the history, from the storage of the history. Right? Mm.
So you mentioned you don't have event buzz anymore. Can you explain to me how your projections work then? Is it a pull model, push model?
So it's a pull model, yeah.
And you use your hypermedia kind of a way of pulling these events from your event store then?
So the hypermedia is actually used more, yeah. We ended up with hypermedia we pushed the RESTful stuff between applications, right, looked after by different teams. And the projections we kept within an application run by one team. So one team would look after the projections required of that data for the different front ends that they looked after. And at the size of our system and the way we'd architected it, each major event-sourced sort of, I guess, bounded context was looked after by a single team that looked after the different front ends, back ends, and things. The one situation where that was not the case was we had a data analytics team, and they were in the department, but they just streamed the events out through their own ETL jobs into Bigtable and stuff like that in Google Cloud, and they just said, we told them, we're not going to offer you any guarantees about the stability of the JSON that you get for these events. If it changes, you just have to suck it up. And they were happy with that.
Don't use event bus for projections. All right.
Okay, all right.
Thank you, Matt.
Thank you.
Thank you, Nat. Sorry. Sorry.